Hello, I'm Zaki Manian. I have been in the blockchain space for many years. I'm an advisor to several projects. I am setting up one of the consortiums that Alex mentioned earlier, the Trusted IoT Alliance. I think there's a natural progression from the previous panel to this panel, talking about the diversity of approaches in terms of evolving blockchain protocols forward. So I think a good place to start is, so Vlad has talked at length about some of his work, and Jay has talked at length about his work, but I think now is a good opportunity for Tom to talk about Dfinity and Peter to talk about Polkadot in a little bit of a detail, just to familiarize the audience with their approaches, and then we can get into some of the differences, in sort of this let a thousand flowers bloom approach to figuring out what comes next in blockchain protocols.
Hi, my name is Tom from String Labs. So we're working on a next generation blockchain protocol called Dfinity. So the goal of Dfinity is to create a decentralized cloud that is powerful enough to support both enterprise computing and large-scale decentralized clouds. I think there are three probably keywords that are defining Dfinity. I think some of the difference of other projects. Number one is we care a lot about scale performance. The first version of Dfinity is trying to achieve 5 to 7 seconds of finality. The second thing would be self-evolving. So we would like Dfinity to have a blockchain nerve system that is going to adapt to the needs, protecting user from hacks and freezing system. So I guess we're a little bit different philosophy from the traditional or the code is law kind of philosophy. We're more into algorithm is law. We think that the network should be self-adaptable to different circumstances. The final pillar, I think, to Dfinity is I think we're pretty opinionated about crypto finance, and we think stable currency is a key enabler, or the lack of stable currency is a problem, is a major issue to mainstream adoption on blockchain. So we're working on a system called Phi that will work together with Dfinity or similar smart contract system that will provide stable currency of dollars and euros and stable tokens on blockchain.
Hello, I'm Peter from the Polkadot project. The Polkadot idea itself is originated from the paper by Gavin Wood, and basically the idea comes from the fact that we are seeing more and more different kinds of blockchains appearing in the space. So we see Zcash that enables privacy. We see Tezos, which claims to make formal verification easier, and we see a number of different ideas popping up for different blockchains. Also, of course, on the enterprise side, we see consortium chains being created because the public chain doesn't have enough capacity to support whatever needs are there. So with Polkadot, we aim to do two main things. So one is provide intercommunication between all the different types of chains, and second of all, make it possible for chains to share their security. So, as Jay mentioned earlier, it's a big problem that if we have different blockchains with separate maintaining communities, if they don't share any of each other's security. So maybe Bitcoin is very secure, but then Zcash appears on the stage and has to build up their own community of miners in order to be secure. So with Polkadot, the idea is to pull the security of all the different chains together. So this is done by decoupling the state machine from the consensus process. So basically, the state machine can be basically anything we want described in a Turing-complete language, and then the consensus for all the different state machines that are running. So there might be an Ethereum-like state machine or Zcash-like state machine. Consensus is achieved in parallel for all the different state machines, and then finally there is a global consensus over all of them, which enables fast inter state machine messaging and full security.
So I think Peter really comes to one of the key points in understanding sort of the trade-offs and the risks of all of these protocols. The benefit is clear. The benefit is our blockchains that are more scalable, a more scalable approach to smart contracts. But the risk is security. We understand the security of proof-of-work systems like Bitcoin, and current Ethereum. But as we migrate to new consensus protocols, there are going to be new security challenges. Vlad has done a lot of really interesting work thinking about the security of proof-of-stake systems on Ethereum and Ethereum's move. And maybe you can talk a little bit about your approach to security, and the rest of you can kind of see, approach what it is that your project is uniquely doing in terms of a secure next-generation blockchain.
Hi, yeah. So I think there's like two kind of main angles on the security question. One of them is in terms of fault tolerance, and the other is in terms of economics. And fault tolerance, I think, is relatively uncontroversial and relatively objective. On the economic front, though, it's a little more interesting, and I think the main thing that I kind of have been pushing, and I kind of think is really important that we think about in the context of these public blockchains, is that there is extreme concentration of wealth in the world and in the blockchain space. And therefore, any weight in the consensus that is kind of determined by economics, by like open participation to the market, is going to be extremely concentrated. And whatever we build needs to be robust to oligopolistic competition, right? To this cartelization that tends to come with, and the coordination that tends to come with, and the lack of perfect competition that tends to come with market concentration. So I think, you know, if there's any like one thing that I like to focus on for security, is security in the context of market concentration and imperfect competition.
So I think we definitely are inspired by a lot of the things that you say about consensus algorithms themselves and how we can analyze them, and it will definitely help us to design, finalize our own consensus. And the economic part is very important. But I think a very important thing in order to achieve both scalability and safety is what Polkadot does is to separate the validity, checking the validity of the state transitions from canonicalization of a particular chain. So validity, we can say that it's an objective property of a state transition, given some verifying implementation. And but then the main issue is to pick a single history of the state transitions. And if we want to do both things at the same time, then the canonicalization becomes the bottleneck, because every single party that is participating in picking a single history has to also validate every single state transition. So I think an important thing when we go towards scaling and ensuring also security will be to separate the two notions, and then we can do validation in parallel, while canonicalization, which is a bottleneck, can be still done directly between parties.
My philosophy for building secure blockchain systems is kind of derived from like the Unix philosophy of creating modular units that can be composed together. So, like the reason why I mentioned earlier that the Cosmos Hub has a very specific focus, it's because I don't think, it would be bad if the scope of the Cosmos Hub were to become diluted with various other things. It would just introduce additional complexity and make it more likely to fail. And if you look at Tendermint, which is a software engine, it's an open source software consensus engine, even all that tries to do is solve the consensus part, a very narrow scope, and it tries to be a reusable component in many other chains. And I believe that by focusing on a particular vertical for each of these components and software products, you can make it more amenable for different projects to use these components, and thereby we can all come to better security by virtue of pooling resources together and research together.
Yeah, I think Definity's approach is heavily kind of driven by the idea of randomness. So if you think about the layers of concerns for Definity, the very bottom layer is that about dealing with simple proof. We have simple proof mining identities, which each represents computation in units. But I think from the day one, we're thinking about very large scale networks that can go to millions or hundreds of millions of mining identities, each of them represent a unit computation. On top of that layer, these mining identities together compose the ability to have a very probable random function output that produce even and stable and fast randomness. On top of that, you have the consensus layer, which produces kind of virtual mining, which are really based on these mining identities, compose a blockchain. And then the final top layer would be a layer that we call decentralized notarization, where it actually accelerates finality within two blocks. So I guess that's a way kind of we generally try to separate the concerns and deal with in different techniques. And there's a number of innovations and applications.
So, along these lines, one of the things that Tendermint has done, or the Cosmos project has done relatively recently, is complete and publish an independent review of the Tendermint component of their stack. Do you want to talk a little bit about independent research on Cosmos? I'm thinking of the Jepsen analysis.
Sure. Yeah. So, yeah, the overriding philosophy in software development, and this comes from Silicon Valley because I've been there for a while. I tried to be an entrepreneur for a while. And the one thing they hammer down, whether you go to an accelerator like Y Combinator or whatnot, is find the problems. Get audits, figure out what the flaws of your product are, and incentivize others to find those flaws and to be absolutely, transparent about the state of where you are, because that way more people can give you feedback. So like even if you look at the development of the Tendermint protocol ever since the beginning, like Tendermint has evolved quite a bit, not just the protocol, but the software itself, and it's always been evolving based on feedback. Like, put something out there and see what people say, and if there is a problem, then we'll fix it. So recently we got testing an audit by the Jepsen group. Or Jepsen is a tool for auditing distributed systems. Like usually, so far it's been used to test database systems, replicated database systems. But we worked with Jepsen to audit Tendermint, and hopefully, there were some issues that were found. That's not surprising, but I think what's more important is that we're looking for these things and we're not embarrassed about them. We will fix all of them and try to make Tendermint the best that it can be.
What are some other sort of key engineering challenges that your projects are trying to overcome in the next months and years, or as you launch your mainnets and then go forward? Can we talk a little bit about engineering milestones and how we are going to get confidence as in the evolution of these protocols? Vlad, do you want to start?
Yeah, sure. So in terms of like the big milestones that I see, there's kind of like a kind of economic modeling that's required in order to parameterize consensus protocols, in order to have like the incentive to be like the solution to some problem that's well defined, right? And so we need like models for participation in the system and models for people's behavior, and we need to kind of like use these to come up with incentives as a solution to an optimization problem that says like, oh, what is the maximum economic security that we can get? And I think that's a problem. That's an area of research that's kind of super interesting and is in the next few months. Looking a little bit further than that, I would say that like sharding and having like a really low overhead in terms of per shard is critical to see these things scalable.
So how would you inform some of your research directions based on the results from some more conservative proof-of-stake systems that are being potentially released like Cosmos, or some of Vitalik's proposals on like a sort of conservative CASP?
I'm not sure. Well, I mean, like, not that much to be honest. Like, I'm focused on kind of like fundamental research and looking for like I mean, I just gave my talk on like my approach to consensus protocols, and I don't see myself really deviating from that. In terms of in the economic stuff, though, Vitalik has done a bunch of work that I think is very interesting. I mean, he has models for participation in the blockchain that he uses to think about discouragement attacks.
Okay.
And basically, there's this really kind of fundamental issue that faults to the liveness faults, where nodes go offline or maybe are censored, aren't perfectly attributable, and so it's kind of hard to penalize for them without introducing elements of unfairness, and then modeling the impact on participation that increased accountability under perfect information leads to is a really interesting thing that I'm like learning, like from Vitalik about.
Cool. Peter?
So there will be a number of different components that will be essential along the way. So first thing will be building those loosely coupled chains using bridges. So this is where kind of chains don't validate each other's state transitions, or just kind of connected by their validators, a little bit like in Cosmos. Then an important part will be to move the state validation logic, state transition validation logic onto the chain. So we completed a WAS-based state machine implementation. So now we can write our contracts in Rust, which is our programming language of choice.
Could you explain what WASM is? Because I'm sure, other than a couple of other people who are most of you on the stage, nobody else knows.
So WASM is WebAssembly. It's a new standard for that is being built for the web to have basically a state machine that would work across like in different browsers. But then because it's such a widely used standard, many people are considering it a very good target for blockchain state machines. So the same way we have on Ethereum, we have the EVM, which was specifically designed for the Ethereum project because there was no real alternative back then. Now we might move towards something much more standard, which is WASM, and there is already lots of projects that enable us to compile regular programs that you would normally write in different programming languages as smart contracts, which makes it much easier to implement more complex logic on the chain, especially if we want to have some guarantees about safety of those programs. So basically for this separation between parachain and relay chain, we need to have the state validation logic basically on chain, so that each validator is able to pick up a state transition proof and be able to verify it, and that will enable us to separate the canonicalization from the validity and collecting the blocks, so that validators have to do as little work as possible, as Vlad mentioned, to minimize the work that they have to perform.
I think the best way to ensure that the blockchain is secure is to put some stake behind it. So, put a bounty behind it. Make something that attracts hackers to try to destroy it, and the best way to do that is to launch a public chain. So with that in mind, we hope to launch the Cosmos Hub very soon. But, it's not just that. Of course, you have to actually work towards making the software secure. So we're talking about two things shortly. One is, kind of like what I was alluding to before, simplicity of a product. That philosophy in Tendermint goes down all the way to the consensus algorithm, where we try to make the consensus algorithm as simple as possible. Because if you have a complex algorithm, people, less people are going to understand it, and that means that different implementations, or even the Tendermint implementation, the one we have over time, might get broken. So simplicity, I think, is a very important goal to strive towards. But security is a difficult thing because there are all kinds of strange ways in which attacks can occur. One thing that comes to mind is, depending on, if you look at Tendermint consensus, the way in which it works, it doesn't use hashing like Bitcoin, but it uses public private key cryptography to come to consensus by these validators voting and sharing their messages with each other. But that cryptography, the public private key cryptography, can also be broken. I just about a month ago, we met a professor who used to be a cryptographer, but then started doing research in the quantum computing field because he realized that the best way to break these widely used crypto algorithms is actually by creating a quantum computer. And he was telling me that, he strongly believes that within the next few years, we will very likely see quantum leaps in quantum technology to the point where, the first thing that's going to happen is we're going to figure out a way to turn the quantum computer problem into an engineering problem. And then soon after that, we will see a lot of our cryptography break. So the nice thing about Tendermint is that it's fairly easy to make it quantum proof because there are known quantum proof public-private crypto algorithms. Starting next year, one of our focuses will be to introduce quantum proofing into Tendermint. I want to mention that Zaki's been doing some work with us there, and thank you for writing that paper.
I think one of our interesting field of research will be the blockchain nervous system. So I think we'll probably be one of the few major blockchains that to be launched next year that will have the first self-development system. And the way that blockchain nervous system works is that it will be a set of smart contracts that can really have super admin privileges that are controlled by a set of basically voting protocols. But the thing is that everything on the edge is completely deterministic, right? So anyone can run a machine learning agent at the edge in your browser Chrome extension that actually analyzes your past Dfinity token performance or something and make a decision on that. It could decide to follow someone. So I think we'll see some really wild experiments on how would that work on public blockchain. That's one of the things we'd like to do more research on.
So one common criticism I hear about sort of next generation blockchain protocols is it's already hard enough for developers to develop on top of the existing set of blockchain protocols. Building Ethereum apps or Bitcoin apps is definitely a trial by fire in terms of having built several myself. It can be a trial by fire to do so securely. This is sort of the last topic, but I think it's an interesting question about how do you think your protocols and your developments will make the lives of developers building on top of these systems easier?
Yeah, I love this question because I think about it a lot, right? And the main thing that I think is really, really critical is that people have to build their applications in a single trust environment only, right? I think having applications have to sit on-chain and off-chain, on this chain and that chain and this chain, and then to link those chains together. It's all really complicated stuff to reason about. I think having a single scalable environment with a single trust model is really going to simplify a lot of this application development. Especially, if you want to develop a scalable application today, it's even more nightmarish. Yes.
Yeah, I would agree that. So with Polkadot, hopefully it will still require building a lot of developer tools, but the developers will be working on the relay chain and basically only having light proofs from all the different parachains. So it will be kind of a single class model. They don't have to worry that one of the parachains will break because that would mean the whole network breaks. But yeah, I think it will be all about building solutions, different libraries in different languages, and abstractions on top of abstractions that make it much easier to reason. For instance, even things like in Ethereum, you have to worry about reorganizations of the blockchain. So even simple things like JavaScript APIs that enable you to only get a response where actually blocks are finalized is already a great boon to a developer. So I think developers.
I think we don't quite know how this application development safety will evolve, but I am excited about Solidity, which was a huge improvement over Serpent and LLL or just raw EVM coding. And I'm also excited about EWASM or WASM, and I'm also excited about other languages. These blockchain companies are coming up with different smart contract programming systems, and I think that's great. We even have our own that releasing at some point. It's just a simple language, no virtual machine, but just an interpreted language as a smart contract system. But I guess our approach to security and in our job in all this, I think, is to provide a limited scope Cosmos Hub so that all of these different systems can be experimented upon. And should any of these systems fail for any reason, the Cosmos Hub will help firewall that failure and the rest of the ecosystem.
So we started working with some of the larger enterprise consulting companies like BCG from the very beginning. So we actually were heavily influenced by how we can help enterprises of the world who are probably mostly Java programmers by training, and how do we get them in at scale into the smart contract world. So I think we have some interesting WASM. So we've been actually working with some of the architects of WASM and Hugo, and Martin BZ from Ethereum Foundation has been working on WASM for the last probably 2 years. So we've been doing quite a bit of work to make that. Solidity today is great, but it's still about 50K, 10,000, 100,000 developers in the world, which is like nothing compared to 10 million or 20 million developers worldwide. So I think there should be a lot more language choices. There should be much more modernized IDEs and tools, compilers, checks, stuff that should be available. So we'll probably have some more announcements in recent months, but I think that's a major thing.
Thank you to the panelists. I think we're at the limit of our time.